Now let's do some practice together on triangles congruency. So let's start off with an easy one. Which triangles are congruent in this diagram? Okay, well, I have a rectangle and then I have a line in between it to make two triangles, right? I have two right triangles. And then I have two right angle measures, which I can even just like immediately I can say that these are equal to each other, okay? So I want to say that angle M is congruent. I'll do it in a different color. I want to say that angle M is congruent already to angle G because they're both 90 degrees. Perfect. And then I see here that this line MN is parallel to HG. Okay, well, they're parallel, but what is this telling me about the triangles? Well, if MN is parallel to HG, that means that this line of HN is called a transversal, meaning that it cuts the parallel lines in half perfectly. And why does this have any significance? Well, I know because my properties of the properties that I've learned of transversals, meaning that alternate interior angles. And because these are alternate interior angles, I can therefore say that this angle is congruent to this angle right here, okay? And so I've already proved that I already have two of my proofs right there. Angle N, and you should actually, because these are similar, you should say that angle MNH is congruent, which I'm talking about this one, by the way, is congruent to angle NHG. And I'm talking about this one right here, NHG. Okay, so I've already have two of my angles. I've already proved that two of the angles of the congruent sides are congruent. So I only have one more thing I need to figure out. There's actually multiple ways you can go about this. But I think the easiest way and that the most obvious way is that because both triangles share one side, both triangles share the side of HN, you can say that HN is congruent to itself. And this is by property, if you already know this is by the property of reflexive property, meaning that HN is HN, that naturally, if like one line, it's going to be congruent to itself. So from what I have here, I've proven one angle and one angle and the excluded side. And then if you look on this triangle as well, one angle and one angle and the excluded side. Let's go back to my postulates. I think that perfectly matches AAS, meaning that triangle, and we need to be really careful about the way that we go about ordering these triangles because, again, as I've said before, if you do it in the wrong way, then the whole statement becomes false. So, therefore, I can say that triangle M, I want to start off with the M because I know M and G are the same, right? And actually, I'm just going to delete all these. Okay, therefore, I can say that triangle M, and then let's just leave a blank, is congruent to triangle G. Okay, and now I can see that N is congruent to H, meaning I'm going to do M, N, and then I know that N here is congruent to G here, so I'm going to write G, I'm going to write H there, and then just complete it. So M, N, H is congruent to G, H, N. And now let's do a little check to see if we're right. Okay, is angle M congruent to angle G? Yes. Is angle N, M and H, meaning this one, congruent to GHN, meaning this one? Yes. And then is angle N on GHN, like this one, congruent to MNH, this one? Yes, also. And then also, I can see that NH corresponds to HN, or it's the same thing, written in reverse. Therefore, my final answer is that triangle MNH is congruent to triangle GHN. Great. Now let's go over a little bit of a different question. So this is a two-column proof, and I think a lot of students also struggle on doing two-column proofs where the triangles are intersected in a way because it can be a little confusing to picture. So that's why let's do this question, okay? Question number 2. It's given. Okay, let's see what's given. Side EG is congruent to IA. EG is congruent to IA, and they've already given me the lines to infer that. And then it's also given me that triangle EGA is congruent to triangle IAG. So an angle, sorry. So angle EGA, this is IAG. My recommendation always is to redraw the triangles separately. So do you see how this makes a lot more sense? Because before, obviously, they were overlapping, so it kind of made it was kind of confusing. But there's a reason why they're overlapping, which it will help us in the 2 column proofs. But it does help to see that they are separately in a way. So let's start at 2 column proofs. As always, when we do our 2 column proofs, we always start off with writing our given statements. So whatever was given, that EG is congruent to IA, one is given. And then another given one that we were given was that angle GEN is congruent to angle AIN. And then that's also given. Now, how am I going to go about this? Well, okay. So I've already done my 2 things, and I basically have 2 of the requirements already. Because if you think about it, with all the postulates that we've done, it's basically 3 things. 3 things that match up to each other, and then therefore you can call the triangles congruent. So I already have 2 things. I have a side and an angle. Now let's try to prove that another side. Let's look at this triangle, okay? And look at this figure. Well, I can see here that G and A are being shared. Therefore, by reflexive property, I can state that GA is congruent to GA. Now, let's say that. Let's write that in our thing. So GA is congruent to GA. And that is by reflexive property. So I'm going to write that. Okay, so I've done that in my diagram. Now let's do it. Okay, so basically in our 2 triangles, I've proven this. But look, I've proven that side match up, the included angle, and then another side, which is what theorem? SAS. Meaning that I've already proved that the triangles are congruent. But the proofs do not say, the question doesn't say prove that the triangles are congruent. The question says prove that angle GEN is congruent to AIN. And I'm sorry, I really messed up here. I wrote the wrong things, but angle EGA is congruent to angle IAG. Okay? So it's not asking me to prove that the triangles are congruent. It's asking me to prove that a certain angle, which is, okay, so it's angle GEN, meaning that it's asking about this angle, and then AIN, this right here, okay? So it's asking me to prove that those angles are congruent, but the way I'm going to do it is by first proving that the triangles are congruent, which I've already done. I can state that triangle EGA is congruent to triangle IAG, and by what property as we wrote down here? SAS. So by SAS congruency. Now, one thing I didn't go over before, but is something you need to know, is the concept of CPCTC. Or in other words, congruent parts of congruent triangles are congruent. Meaning that, say for example, you had triangle A, B, C, and triangle D, E, F. Okay? And then it's telling you that, what's given is that triangle A, B, C is congruent to triangle D, E, F. Based on this postulate itself, by CPCTC, congruent parts of congruent triangles are congruent, meaning that this congruent part, A, B, and D, E, those are congruent. Angle A and angle D, those are congruent. Angle C and angle F, those are congruent. So going back to our question, by the postulate of CPCTC, because I've already proved that the triangles are congruent, I can then say that angle GEN is congruent to angle AIN by CPCTC property. And we're done. Now let's move on to the next question. The question says that if AF, line AF, is congruent to DE, and AB is congruent to FC, and AB is parallel to FC, what theorem / postulate can be used to prove that angle ABE is congruent to angle FCD? Well, let's try to figure out, how are these triangles congruent? Well, first things first, when you see a triangle like this and you see that there's lines being shared, your mind should always just be wired to say that that is congruent. So I can already say that FE is congruent to FE. Okay? That should just be a thing. Okay? And so then I basically I already have that this line right here. Oh, okay. And then let's draw the triangles separately again. So this is the same thing as that. They're just overlapped in a way. And I've already proved that it's been given that AB is congruent to CE or EC. It's already given that. And I knew by reflexive property FE is congruent to FE, right? Meaning that from AF was already given that AF is D. Meaning that if AF plus FE is one thing, then you can say that the same thing, F to D, is also congruent. That's a property that's side congruency addition. That's a postulate. Because if you think about it, if AF, the measure is 2, and DE, it says that it's similar, so it's 2. And then FE is the same line. So FE can't be two separate numbers. You get what I'm saying? FE is 4. That means that 2 plus 4 from A to E is 6. And then from F to D, that's also 6. Do you get what I'm saying? So I've basically already proven that AE is congruent to FD. Now I just need to prove, I have 2 of my requirements. I just need one more requirement. I need one more thing to prove. Well, they didn't tell me that these 2 lines were parallel for no reason. There's a reason. Usually when they tell you a line is parallel, it'll always be for a reason. And so here, if I can see here that I have 2 parallel lines, and then I have 2 transversals, right? These 2 lines are transversals, whether or not they were intended to be transversals, they are. And I know by property of transversals that if I have a transversal, and I'm just gonna really flip this whole diagram around just for ease of mind, to make the transversal straight. So here I can see that I have 2 parallel lines, and then I have this transversal, right? And I know by properties that if this is a transversal and these are parallel lines, then by corresponding angle theorem, this angle, otherwise known as A, is congruent to this angle of F. Meaning that I can write here that angle A is congruent to angle F. Okay? And so now if I go to my 2 diagrams, I've proven that angle A is proven to angle F. And then if we look, we've proven that a side, and the included angle, otherwise known as SAS. Again, also SAS. Meaning that in the question it says what theorem or postulate can be used to prove that angle ABE is congruent to a triangle FCD? It's SAS. That's our final answer. SAS, congruency. So the last one I want to do with you guys is question number 4, which is another 2-column proof, which I also find that a lot of students struggle on a lot, but it should not be too difficult. Again, it's kind of like the same same concept as the previous ones we've done. Okay, so it's a two-column proof. My first things first, what I'm always going to do is I'm going to write my given. So statement dA is congruent to yn. That's given. And then dA is congruent to yn. And I meant this was parallel. And that's also given. Now it's asking us to prove that angle NDY is congruent to angle DNA. Okay, let's look at this again. So I know that these two lines are congruent, which is great for us. But then I also see that these are parallel, meaning that this line of DN is R transversal. First things first, I've already told you guys that if you see a line that is shared between two triangles, that's always going to be congruent by reflexive property, meaning that I can say that DN is congruent to DN because of reflexive property. Okay? So I've already proven two sides are congruent. And then I just told you guys that this line of ours is called the transversal, correctly? And then what we already know by properties of transversals that alternate interior angles are congruent, meaning that D and N are congruent, and then this D and this N are congruent, right? So I'm just going to do like that to make it easier on you guys. And so I can see here that what I've basically done is that I found two sides and the included angle, which is again SAS congruency. So let's go into our two column proofs and write down what we've done. I said here that DN is congruent to DN by reflexive property. And then I just then proved that this angle ADN is congruent to angle YND. And this was by alternate interior angles theorem. And now I can then prove that what I told you guys, S, right? So triangle ADN is congruent to triangle. And I want to be really specific about my angles that I'm saying are congruent. So Y and D. And this was again by SAS congruency. And then, but it's not asking me to prove that the triangles are congruent. It's asking me to prove that NDY, meaning that this angle right here, is congruent to DNA, meaning this angle right here. Well, I've already proved that the triangles are congruent, meaning that by CPCTC, I can prove that NDY is congruent to angle DNA by CPCTC, or congruent parts of congruent triangles are congruent. And that is going to be all for today. I'm sorry that all the questions were SAS, but you guys definitely just do more and more practice. Watch my video again and watch all the concepts again, and you guys will be fine. Thank you guys so much for watching, and have a good night.